So I'm going to start the project here. You've made it. Hell yeah, welcome. My name is Haza. I think it's Raza. Haza, not really sure. And I'm going to be your installation wizard to the blockchain. This project is for devs who want to understand Web3 apps by just building one themselves. All you really need to know going into this, some terminal skills, some JavaScript, some React.js. Connect your Discord in the project dashboard. All the good stuff is going to be happening in a secret category in the Discord that you only have to access through once you connect your Discord. Connect your Ethereum wallet in the project dashboard. I made the MetaMask account for this, but apparently the available options that they offer don't have MetaMask. So I decided not to do it on another one. So if it is necessary, then I'm probably gonna have to do it, but otherwise I'm more interested in the project itself. Because from what they say here, after you finish the project, they give you an NFT. But if you don't have the wallet, then you don't receive the NFT. But yeah, I don't really care about that much. And if you don't have a wallet connected, we won't be here. Yeah. Be sure to attend the live kickoff. If you miss it, no worries. It's not required to attend. The recording will be, oh yeah, I think I'm gonna stay here for 2 hours. Then I'm gonna take a break. So let's, the problem.
Hey folks, welcome to the Polygon project. I'm Reza. I thought I'd make a quick
this.
video showing you guys what we're actually going to be making. So this is a domain name service application on the Polygon.
I'm still not able to listen to it. So I might have to reopen the thing.
Hey folks, welcome to the Polygon
There we
project.
go.
I'm Reza. I thought I'd make a quick video showing you guys what we're actually going to be making. So this is a domain name service application on the Polygon blockchain. If you've used ENS before, it's a lot like ENS. We're going to be selling domains on the blockchain, and we'll let anyone set records or data for their domains. I've called mine the Ninja name service. I've gone with a GIF of a ninja doing some funny stuff. You guys are welcome to do whatever you want. You can, name it anything else. Maybe you want to go with, I don't know, .maxi, .rotator, whatever it is, whatever you vibe with. Maybe it's even just .vibes or just .toast. You're welcome to just update the UI as much as you want. But this is my version, and this is what it's going to look like, or it should look like, close to the end of the project. I'm just going to get started and click connect wallet. That is going to pop open my MetaMask. It's going to ask me which wallet do I want to connect. I am going to go with my main one for the Polygon blockchain. I'm going to click connect. And let's look at this. It's asking me to actually switch to the right network. I can see I'm currently on Ethereum. Since we're going to be deploying on Polygon, it's going to make me switch. I'm going to click switch. And we're actually going to be building out this functionality. You'll learn how to make people switch their networks. 8 things in a domain. We can set the record and go with it. Cool. It's going to pop open my MetaMask, and it's actually going to ask me to pay 0.03 Matic. So I'm going to click confirm because I'm okay with it. I can see something's happening now. What's happening here? Data for the domain, which is I can actually look at this, and hopefully it'll be done. If not, I'll just show you some other ones. I'm going to go here.
So it's a website that allows you to build domains, to sell domains. Super excited to show zero shipping your own Web3 app on a Polygon layer 2. What does shipping mean? Well, it means you actually make something and deploy it to the internet for the world to see and use. You'll be able to show the final project off to your friends, potential employers, and even your dog. The best part is, your follow-up with Buildspace will be first users for your project. So it's very new, there's a lot of hype around it, and it can be super difficult to understand the best way to learn it. With this project, you're going to learn about crypto tech by actually writing code, And just hopping into the good stuff. No BS. We also go over theory more in-depth concepts, but it will all be structured around your project. When you have questions, okay, it's an issue. Scope completely open source. If you see. People seem to think Web3 just needs people who can code smart contracts or write code that interfaces with the blockchain. Not true. There's so much work to do, and most of the work doesn't even have to do with smart contracts. Being an engineer on Web3 just means you take your Web2 skills and apply them to Web3. Web3 also desperately needs designers, product managers, marketers, and more. We're partnered with a bunch of awesome Web3 companies. I want to hire people from the Buildspace network. We got companies like OpenSea, Edge, Node, and Chainlink as partners. Even if you're just curious, click Working Web3 on the sidebar in your Buildspace dashboard. So this is very interesting, of course. Fill out the form real quick and check out the opportunities. Worst case scenario, you get to talk to some really cool people in Web3. Progress report, please do this. Raza website, Raza. Go ahead and say GM, good morning, in GM only on Discord. I already got into their Discord in my other account that I had, and I created this one just to do this on stream. So, yeah. If you don't do this, then all of you may jump in Zerper. If you want to make a tweet telling the world that you're building your own ENS today, go for it. We always say this, but one. It's personal, okay. But it's gonna be a problem if. Okay, so you don't actually have to go there. Before I get deep into coding up our domain service, let's talk a little bit about why Polygon is an applicant solution for this. This project is about making your own domain service where people can buy their own domain from your smart contract and own it. When you're making people pay for things, you generally don't want them to pay 40 in transaction fees, which is how much Ethereum transactions cost on a good day. This is where Polygon comes in. I wonder if Ethereum already is proof of stake. I think not. Maybe in July they'll change. I know they're going to change and it's going to be soon. So maybe the fees will change once they move to proof of stake. But $40 a fee for a transaction is just ridiculously expensive. Technically, Polygon is a protocol and framework that consists of a bunch of different blockchains. We're going to be building on their most popular chain, Polygon Pulse chain. It's another chain that runs alongside the Ethereum and periodically submits checkpoints to it. A bit. So, I think it's proof of stake chain. The Ethereum blockchain is referred to as a layer 1 blockchain because you can build other blockchains on top of it. That's exactly what the Polygon Pulse chain is. It's a blockchain built on top of Ethereum that runs in parallel, making it the second layer. Imagine you're running a kitchen as a chef. It'd be pretty annoying for you to have to take the order, go back to the kitchen, cook it, and then serve it. You'd get backed up with traffic pretty quickly. Instead, you would hire a team of waiters to act as a layer between the kitchen and the customers. The waiters would then take the orders more efficiently and give them to the kitchen directly. Yeah, that's a very good analogy. This is similar to the relationship Ethereum has with Polygon. Ethereum wasn't built to handle an insane number of transactions, so it gets back up quickly. Polygon is able to handle higher transactions count, and then it bundles up all those transactions up and deposits them to Ethereum as the final source of truth. So it's like the thing I was reading before. It still doesn't make any sense. When everybody wants to start actually building, it will become 10x clearer. Clearer. I don't know how to say this. Actually, I'm gonna put on translator just for curiosity.
clear,
Clearer.
clear,
Yeah. You might be thinking, do I really want to learn how to use another blockchain? Oh no, you don't, since the Polygon Pulse chain is EVM Ethereum virtual machine compatible. Everything that runs on Ethereum can also run on Polygon without any changes. And I think this node that I did is it finally catched up to the it's updated to the present day, and the database is here the address. So the information gets stored on that address in the beginning. So later on, I'm gonna watch that. You don't since the Polygon can also run on Polygon without any changes. This makes it super easy to move contracts to Polygon, so you don't have to sell your candidates to pay transaction fees. For most dApps, Polygon just makes a lot more sense because of how much faster and cheaper it is. All the popular Ethereum tools such as Hardhat, Remix, Truffle, and Web3.js work on Polygon. So that's great. All you need to do is change the network your own. If you've ever bought a domain using Shopify, Namecheap, or GoDaddy, you've used a domain name service. ENS stands for Ethereum Name Service. They created the Ethereum domain that you see being used all over the place. It's cool, but what's the point? Basically, it means you can literally create your own domain service without asking anyone for permission. Usually, you would have to go make deals with big ISP providers to have your domain accepted by them. For example, if you wanted to make the domain bing boing boop boopity boop, then all the big internet providers would need to accept it on their end. Else, the domain would just lead to a does not exist error page. Recently, I wanted to buy AF domain, but it doesn't exist. In this case, I could take inspiration from ENS and build my own ENS for the AF domain. How Now that we know how high Polygon is and what ENS is, how does this all fit into what we are building? We're going to be making a smaller version of ENS on the Polygon blockchain. Let anyone buy a domain NFT and point it to something. This is awesome. This is awesome because once your contract is on the blockchain, any data it has will be universal. Anyone can read the names and look at what it's pointing to. And because blockchains are so unstoppable, no one can remove your data or kill your app domain. By the way, making a new top level domain like dev or nat takes 4 or 5 years and costs like 185,000 in the Web2 world. We're going to do this in a weekend at the cost of a few cups of coffee. Super cool, definitely not expensive Ethereum name service. The biggest issue with NS is the transaction fees. To register a name, you need to pay gas fees to the Ethereum blockchain. Here's how much it would cost to register the domain name expensive name service for a year. That's like 42 Happy Meals. Imagine how happy you would be for sure. Okay, so to register a name, you should pay gas fee for Ethereum blockchain. Here's how much. Okay, so the Ethereum cost is to keep, I think. I would just register for 10 years, save gas fees. It will only come out. Yeah, sure, but it's still too much for some folks. The bigger issue is that anytime you want to update the record or change wallets, you need to pay 30 or 60 for gas. That adds up. These are missing out on. These gas fees are going away anytime soon. You need to pay to store data on the blockchain as long as people find it now to do so. So this is just the explanation. Okay, they have a lot of different things. Talking has actually built their own version. Hopefully, posting progress or fave app. I don't think I'm gonna do anything here. Just type anything. Don't wanna spend time thinking about this. Rather move on to the beginning. If you've taken previous projects at Buildspace, many of the initial setup items in the next few lessons are repeated from previous projects. If you already understand it, awesome, you're pro. Let's do it really fast. Little blockchain primer. Before anything, we will need to get our local Ethereum network working. This is how we can compile and test our smart contracts code. Now you need to spin up your local branch code. For now, all you need to know is that a smart contract is a piece of code that lives on the blockchain. Think of sort of like yourself. No, actually, once the bigger picture here is we're going to write a smart contract. The contract has all the logic around our domains. Our smart contract will be deployed to the blockchain. This way, anyone in the world will be able to access and run our smart contract, and we will let them mint domains. We are going to build a client website that will let people easily mint domains from our collection. I recommend also reading over these docs when you can for fun. Oh, it's the docs that I was reading before. Yeah. I'm probably gonna see if there's anything else that's interesting here, which probably there is because there's a bunch of stuff here. But I won't look into this now. Ethereum works in my opinion. Set up local tooling. We're going to be using a tool called Hardhat a lot, which will let us quickly compile smart contracts and test them locally. First, you need to get node npm. We recommend running Hardhat using the current LTS node version. You can find the current releases here to load node. Already did that. Let's head to our terminal. Git bash will not work. Go ahead and cd to the directory you want to work in. So I guess I can do this directly from here, so I don't have to go into the directory. And probably I need to do the command prompt. Maybe it will ask me for permission, and if that's the case, then I might have to actually open the terminal. cd once you're there, run these commands. So I guess this is just making a directory for the project. I can init here because this is gonna be my directory. And then install Hardhats. Save the Hardhat. You may see a message about vulnerabilities if you run less command and install Hardhat. This is kind of weird here. Don't know why it seems like it's cutting out the text of the page. So I'm gonna leave it like this. Yeah, I don't understand why this is happening here. Every time you install something from npm, there is a security check done to see if any of the packages the library installed has any reported vulnerabilities. This is more a warning to you so you're aware. When npms can break things, so it's better to just skip it. Go on a bit about these vulnerabilities if you want to know more. Now, you should. So, it's similar to the way that React is initialized with this command to create a project, I think. That it's gonna create a file structure and download all the folder structure and download all the files. To create a basic, simple project, say yes to everything. So I guess I just press enter. Okay, yeah. So move around with the arrow keys, and I think it's just a sample. And yeah, is this add a git ignore. No. Yeah, I created all the files. These are the node modules, the contracts, and the test. The sample project will ask you to install hard hat waffle and hard hat ethers. These are other goodies we'll use later. Go ahead and install these other dependencies just in case it didn't do it automatically. So npm install. I think I'm gonna. It's better actually to write, just so I train my memory. Hard hats, waffle, through waffle, try, no collapse. The only issue with writing is that I might miss something. I think I did it correctly. You also want to install something called OpenZeppelin. Well, this one I saw on the Crypto Zombie stuff. That's used to develop secure smart contracts. We'll learn more about it later. For now, just install it. Finally, run npx hardhat accounts, and this should print out a bunch of strings that looks like this. These are return addresses that hardhat generates for us to simulate real users on the blockchain. This is going to help us a ton later in the project when we want to simulate users minting domains. Is this working? So I think I should run this and then save it. I'm gonna grab some water, be right back. Okay, so it's finished installing here. So now I have to install. I think this was the last one that I did. npm install open Zeppelin contracts. And then I have to run this and probably save this address for later. So I think it worked. Make sure everything is working well and impacts hardhat compile. So maybe I don't need to install this. I think I'm gonna store it though, just to be safe. So here. So now I have to run npx hardhat compile. Then npacks. And this probably creates the artifacts with the binary, abstract binary interfaces, I think. Hard hat, tasks. Contracts, the JSON. Also, it's not contracts, it's not the binary interface, it's just JSON files. Okay, so it worked. Go ahead and open the code for the new project now in your favorite code editor. We want you to delete all the lame starter code you generated for us. We don't need any of that. Go ahead and delete the file sample test.js. So guys, it's here. Also delete sample scripts.js and the scripts. Then delete greeter sol under contracts. I don't think I delete it. Don't delete the actual folders, okay? I thought when you compile, you generated the ABI stuff, but apparently you do not. And I'm not exactly sure what these files do. Or how they communicate with the blockchain. Before I click next lesson, notes if done this. Add your progress and post a screenshot of your terminal showing the output of the task. You just ran a smart contract, that's a big deal, shut off. If you don't have access to your progress, be sure you linked your Discord, join Discord itself. Okay. Or do I have to do this? Oh, maybe I can just upload here and not get into the Discord. But this is kind of annoying, honestly. That you have to do this to pass. Or maybe you can just click somewhere to go. Yeah, I don't see the button for the next lesson. Okay, next lesson. You already know how to do all this stuff. Wave portal. We're ready to start writing smart contracts. We're just going to hop right into our project. Open the project folder in your favorite text editor. Follow along. Ask questions. Create a file named domains.sol under contracts. So here, domains.sol. File structure is super important when using hard hat, so be careful here. I recommend downloading the Solidity extension for VS Code. I already did that. I can just go here and then download Solidity. And I think it's this one. Really basic contract, just to get things going. So it's gonna have this license thing that I always forget how to write, and pragma solidity in the version 0.8.10. Imports, hard hats. for some reason it's not opening and closing the brackets. So maybe I should download the other extension. I think I'm gonna install all of this. Or maybe just this one, see if it changes there, anything. So contracts, domains, structure. So this is giving me problems, so I think I'm gonna have to reinitiate to get rid of that. This is my domains contract. Nice. I don't understand why it's not closing, opening, and closing the strings though. So let me close this. Sometimes VS Code itself will throw errors that aren't actually a problem. For example, it may underline the hard hat import and say it doesn't exist. This happens because your global Solidity compiler isn't set locally. If you don't know how to fix this, don't worry, ignore this for now. So your global Solidity compiler isn't set locally. So it's probably like Python where you have to set up the interpreter on the VS Code. But not an interpreter, but the compiler in this case. Ignore this for now. Also, I recommend that you don't use VS Code's terminal. Use your own separate terminal. Sometimes the VS Code terminal gives issues if the compiler isn't set. And that's annoying. Just a fancy. So this is basic stuff. I'm gonna skip through it. You got smart contract, but we don't know if it works. We need to actually compile, deploy it through our local blockchain. Is there the console log will run? We're just going to write a custom script that handles those three steps for us. Go into the scripts directory and make a file name run.js. This is what run.js is going to have inside. So an asynchronous function, main contracts factory. We'll close that so I have more space. Sometimes this can be annoying. Domains. And I'm writing it down just to exercise memory. Because subconsciously you retain more information when you write, so once I feel like I'm already used to the way that things work, I'm gonna stop writing, then just copy the stuff. Console.log, contracts, deployed, true, domain contracts, address. So you're waiting the HR ethers get contract factory. I think I saw these commands as well on the crypto zombies stuff. This is probably the one that applies. Yeah. Const from main. Close async. Try. Main. Process exits. There are playground to mess around with our contract. VS Code might auto import ithers. We don't need to import ithers or anything, so make sure not to import anything. Again, going line by line. This will actually compile our contract and generate the necessary files we need to work with our contract under the artifacts directory. Go check it out after you run this. Okay. This is pretty fancy. What's happening here is Hardhat will create a local Ethereum network for us, but just for this contract. Then after the script completes, it will destroy the local network. So I guess it's the same stuff that the lessons on Crypto Zombie were talking about, where it has to destroy the contract every time after you're done deploying. I don't remember exactly why, but I think it's not should not clog the network with a bunch of contracts every time you deploy or something like that. So every time you run the contract, it will be a fresh blockchain. What's the point? It's kind of like refreshing your local server every time, so you always start from a clean slate, which makes it easy to debug errors. Yeah, so maybe it was not the reason I was thinking there. We'll wait until our contract is officially mined and deployed to our local blockchain. That's right, Hardhat actually creates fake miners on your machine to try its best to imitate the actual blockchain. Our constructor runs when we actually are fully deployed. Finally, once it's deployed, domain contract address will basically give us the address of the deployed contract. This address is how we actually find our contract on the blockchain. Right now on our local blockchain, it's just us, so this isn't that cool. And there are millions of contracts on the actual blockchain. So this address gives us easy access to the contract we're interested in working with. This will come in handy when we deploy to the actual blockchain in a few lessons. For run this, be sure to change solidity to solidity 0. Okay, so I think I already did this. It was 0.8 actually in the tutorial, I think. Oh, and it has to be on like this. Maybe not actually. Let's open your terminal and run npx. What's going on? I don't know what's happening. Just gonna open another one. npx hardhat run scripts run.js. So I think I did write correctly. Cannot be compiled, see reasons below. Solidity version pragma statement in this files doesn't match any of the configured compilers in your config. Oh, so it was talking about changing the version here, maybe? Oh, so yeah, okay. So this was from here, not from the domains. Makes sense. Okay, so let's try again. So now apparently it works. Okay. So deploy it through this. That's pretty cool. And then console logged this phrase here. Pretty easy to actually. In these code blocks, you constantly notice that we use hre.ithers, but hre is never imported anywhere. Directly from the hardhat docs themselves, you'll notice this. The hardhat runtime environment, or HRE for short, is an object containing all the functionality that hardhat exposes when running a task or script. In reality, hardhat is the HRE. So what does this mean? Every time you run a terminal command that starts with npx hardhat, you're getting this HRE object built on the fly using the hardhat.config.js specified in your code. This means you'll never have to actually do some sort of import into your files like const require hardhat. So it gets from here, I think. Yeah, that's what it's saying there. And then it's exporting the Solidity version. You will be seeing HRE a lot in your code, but never imported anywhere. Check out the hardhat documentation to learn more about. Post a screenshot in progress with output off. Okay. So I'm just gonna create a bunch of this and then delete them once I'm done. New space 1. From here, let's add some fanciness to our contract. The whole point of a name service is to help direct people to your place on the internet, just like you type in google.com to get to Google. People will be able to use your name service to go to wherever they want. This is where we do that. Users are going to send us a name and we're going to give them a domain for that name. So first thing we need is a function they can hit to register their domain and a place to store their domain, their names. So this is on the contracts. So create a mapping. String to address. Public domains. Then the function register that adds their name to our mapping. I heard somewhere that you shouldn't be using all data to store things because it's expensive. So, but I don't understand really well the difference. So maybe I can store in a different way as a challenge. Function gets address string public view turns address turn domains. Yeah. So let me search real quick what is call data. I already saw this, but I'm gonna see it multiple times until I understand. Storage, memory, stack. Yeah, memories and stack I think are the least expensive, and storage is the most expensive from what I remember. Data from external calls to functions is stored. Functions can be called internally from within the contract or externally. When a function's visibility is external, only external contracts can call that function. Such an external call happens, the data of that call is stored in call data. So, but what's the difference between this and this stack? Oh, it's almost like memory. It's a non-modifiable and temporary area that can be used to store function arguments. As copying between memory and storage can be quite expensive. Okay, so it is an alternative to memory that's probably less expensive. So it's probably confusing call data with storage. And that's why I thought that it was more expensive. We added a few functions here, but also the domains mapping variable. A mapping is a simple data type that maps two values. In our case, we're matching a string domain name to a wallet address. This variable is special because it's called a state variable, and it's cool because it is stored permanently in the contract's storage, meaning anyone who calls the register function will permanently store data related to their domain right on our contract. We also use some magic here if message.sender is the wallet address of the person who called the function. It's like built-in authentication. We know exactly who called the function because in order to even call a smart contract function, you need to sign the transaction with a valid wallet. In the future, we can write functions that only certain wallet addresses can hit. For example, we can change this function so that only wallets that owns domains can update them. The get address function does exactly that. It gets the wallet address of the domain owner. So yeah, it accesses the mapping, returns the mapping to the argument here. At the name, you pass the name, and then it returns the domain. Domains is the mapping. And this is the address equal to the address. Updating run.js to call our functions. It's time to run again, but run.js needs to change before we do that. So it's this one. Now that we have some functions to call, we can use run.js to manually test them out. So how would I do that? So here is getting this contract and putting into this variable using the hard hat object with ithers, and then this is deploying this. So I don't see what needs to be changed here. When the power contract blockchain, which we do when we run domain contract for deploy, becomes available, which we called on the blockchain because we use the special public keyword on our function. Think of this like a public API endpoint. So now we want to test those functions specifically. So they changed this line. Contracts, blind. Oh, I think I got it. It's just adding extra stuff to check if it works. But owner, okay, it's here. I'm not sure what getSigners does, but I think he gets the transaction, the message the sender thing from the contract. But maybe not because it's not specifying the contract here, so. Oh, and then there's still more inside of this function. Cons domain contract.register. I'm not sure if this is gonna be really useful to learn because it kind of has the tutorial kind of vibe. I'm just following along. Yeah, so the domain contract is the object of the contract that was deployed and is accessing the address. I don't know why it's passing DOM though. And then run main doesn't change. In order to deploy something to the blockchain, we need to have a wallet address. Hardhat does this for us magically in the background. Here, I grabbed the wallet address of the contract owner and I also get a random wallet address and call it random person. This will make more sense in a moment. I also added this owner.address. I'm doing this just to see the address of the person deploying our contract. Yeah, one thing is that I don't understand is if I deployed the contract, I didn't access my MetaMask, so, and I also didn't specify a network. So maybe they probably will talk about that in the future, because I'm still on the section 1 thing. The last thing I added was this. Just like before, let's manually call our new functions. Oh, it's passing a random name, I think. Yeah. So it's registering the random name and then passing to this. That's why. And this function creates a new element on the mapping based on the name with the message.sender address. Just like before, let's manually call our functions. First I call the function to register the name Doom. Then I call get address. Guys, let's run this, then shall we run the script like we would normally. Registering the domains on the blockchain. So the messages are slightly different, but I think it worked. Storing records. Very nice. So we now have a way to register domains on our smart contract. We now need a way to have that domain point to some data for us. At the end of the day, that's what a domain does, right? It's a thing that points to something else. Think about this as your domain's DNS settings. You know how you can go to Namecheap or Cloudflare and customize the DNS records associated with that domain? Same thing here. We're building our DNS record system. With ENS, you can store a bunch of different stuff like I showed previously. To complete the name service part of our app, we're going to add records to each domain. This means we'll connect each name to a value, sort of like a database. These values can be anything: wallet addresses, secret encrypted messages, Spotify links, the IP addresses to our servers, whatever you want. I'm gonna go with strings because I've been told I talk a lot. And now I want to talk on chain. Here's what my updated contract looks like. So this one is different, the message. So they created another mapping there with the records. It's gonna be the stuff that the domain's pointing to. And then they added a require. This is requiring that the address equals to address 0. I'm not sure what this does. It's an unregistered many nodes. Okay. Oh, so maybe every time you add a new domain, it's gonna be on the index 0 of the mapping. That's probably what this is doing. So if it's not in the index 0, it already exists. So get address didn't change. And the function sets records. String call data name. Call data records. Public. Acquire domains name. Sender. Records name. Records. So it's creating a getter and setter for the records. So this sets the record probably, and this gets the record. Check that the owner is the transaction sender. Check that the owner is the transaction sender. I think this one is incorrect, probably. I think they copied the description twice here. Records name equals records. So that's the other mapping. This is another mapping. The only new things here are the required statements. People. That's what is happening here in a contract. The required logic fails. The transaction is reverted, meaning that blockchain the data doesn't change. Let's take a look at this requires. Here we're checking that the address of the domain you're trying to register is the same as the zero address. The zero address is in Solidity is sort of like the void in the literal sense, where everything comes from. When an address mapping is initialized, all entries in it point to the zero address. So if a domain hasn't been registered, it will point to the zero address. This one is pretty easy. Check that the transaction sender is the address that owns the domain. We don't want to let anyone set their domain records. So I'm not really sure if I truly understand this. I think I do, but so domain's name is the address of this mapping. So it's requiring that the domain's name equal message. That's also it's setting the record for the domain. That's why it's checking. So it's checking if it's the owner that is trying to set it, and if it's not, then it's not gonna allow it, and if it is, then it's gonna change the records to whatever the argument is. I think I understand now. Alright, it's time to test this thing out. It would be pretty boring if we could only send and register our domain. Everyone just use our domains. Add a few lines at the bottom of the function. I'm not going to explain it much, but please ask questions in general through chat. Basically, this is how we can simulate other people hitting our functions. So now it's the run. So up to this point, I think it's the same. And then it changes here. Instead of const is let. Await the transaction. So this part is the same. And now it's changing here. Because await the main contracts. Not connects random person. Not set records. Dom. Aha, my domain. No. Yeah, so just accessing the function. But disconnect, I don't think that exists here. So it's probably some function of the hard hat thing. Also, it's probably connecting the random person, which was created here, is making that random person call the contract. I think that's what this is doing. And then it's calling the function set record. Yeah, it's probably really sure that, really confident that this is what's happening. So the newest items added to this code block are, and okay, running this script will give you an error, want an error. That's because we're trying to set a record for our domain that isn't ours. Now our required statement to work. Note if you don't do this, Raza, I think I'm gonna run this just to see. Customize the code a little, feel free to play around with the contract and run JS file and register multiple domains and set all sorts of records. We want people to map their domain to their email address. Would map to my email. Or maybe you want people should be able to add the IP address of their personal websites as a record. You could even have the domain map show an SVG of the person's favorite meme. Whatever you want. The supported data types are the limits. Even, okay, so let's see. Random person is not defined, so maybe I made a mistake here. Oh yeah, I typed the wrong way. I was also thinking it was weird that it didn't highlight there. So let's try again. The supported data types are the limits. Even if you just change up the variables names and functions names should be something you think is interesting. It's a big deal. Try to not straight up copy me. Think of your final website and the kind of functionality you want. Build the functionality you want. Once you're all done here, be sure to post a screenshot of your terminal output in progress. So the one thing I'm most curious about this is the actual deployment to the network using the MetaMask wallet. So I don't think I'm gonna spend much time because I'm not particularly interested in this project itself. And I think I'm gonna use hard hats to do the testing stuff when I'm building the project that I'm actually gonna build for myself. So I'm probably gonna read the documentation on hard hat and Web3 and spend a lot of time trying to understand that. So I'm not gonna spend a lot of time doing this stuff like he said here to change the contract and do my own thing. So I think it worked here. It's reverted the contract because of the require statement. Be sure to support the term. Okay, so screenshot again. It is an interesting idea though. I can think about several things that might be possible to do with this, but then I'm gonna lose track of the stuff that I actually wanna do, so that's why I don't wanna do. Don't wanna spend a bunch of time focusing on this project specifically. Just wanna focus on the stuff that I actually wanna learn. Our contract is starting to take shape, but we're just giving away mappings right now. You can't really view them in your wallet or on OpenSea. That's not very cash money. What we're going to do here is turn our domains into NFTs that are viewable on OpenSea and sell them for different amounts depending on how long the domain is. By the way, ENS domain at this part seems very interesting. ENS domains are just NFTs under the hood. It's unique and only one wallet can hold a certain domain at a time. If you want to learn about what an NFT is, click here for a primer before moving on. As long as you have a general idea about what an NFT is, you're Gucci. So basically NFTs are no fungible tokens, which is basically a unique address, I think. Yeah. That is unique on the blockchain, so it can't be copied. And is useful for ownership of stuff. To make it less bureaucratic, if that's a word. To pass ownership of things. I think right now everybody uses for pictures and stuff like that, but probably in the future, not sure how long it will be used for transferring assets between people, like houses and cars and stuff like that. which is just far easier to just pass around with NFTs. But because of the energy and the bureaucracy of things, until things change and the laws and stuff like that, it might take a while for that to happen. Weirdly enough, we haven't actually put a TLD top level domain like Ethereum in your contracts. Let's set up a domain that we want our friends to be able to mint. I'm going .ninja. Please change this to whatever you vibe with. Maybe it's friend, vibes, or just toast. So this is on the contract again. So I have to import from libraries string details.song. So this might be because of the VS Code thing that they talked about earlier. Or maybe because I'm specifying the folder correctly. Libraries, don't forget to add this import. Libraries string utils.so. Yeah, there is no libraries here. So maybe it's one of those hard hat things that is gonna figure out when it runs. So it added a string public TLD. So it's making constructor payable. And adding string memory TLD. We make the contract payable by adding this constructor. So it's making TLD equals TLD, which is this variable on the constructor. So every time you call a contract, it's gonna generate a new TLD based on this. I think. I'm not really sure. So what else? Function price. String call data name. Public pure returns. Joins. Five matic, 18 decimals. We're going with 0.5 matic because the facets don't give a lot. So this is converting the units from matic to Ethereum maybe. So 5 matic is equals 5 billion. 5 whatever this number is. And now let's see. To charge smaller amounts, reduce the decimals. 0.3. That was 70. So the other stuff is probably the same. It raised all the other stuff. So then it has the require before. Message the value equals price. Not enough. Medic paid. The rest is the same. We still need the get address, set record, and get record functions are just unchanged. You'll notice something extra spicy here. We added payable to register. I also added so payable to register. I didn't even notice that. So that should be payable here. Yeah, because you have to pay to register. And I guess message.value gets the amount that the person calling the contract has. Int price equals price name. What is this price name? Oh, so it's the function here. Just calling this function with the name. And then it's calculating the length of the string. So the price is based on the length of this string. That's what it seems like. Yeah, but I still don't see what's the moment where it's charging the person. This requires are checking if there's enough balance, but if the value of the message sent is above a certain amount, value is the amount of medics sent and message is the transaction. I want you to take a minute to appreciate how insane this is. With just one line of code, we can add payments to our app. No API keys needed, no auth, no callbacks from payment providers. This is the beauty of the blockchain. It's built for transacting value. If the transaction doesn't have enough medic, it gets reverted and nothing changes. Looking closer at the price function, well, I guess every time you call a contract, you have to pay. So that's where the charging takes place. I'm not really sure though. I will make the contract payable in the constructor. Maybe they will talk about this later. Looking closer at the price function, we see that it's a pure function, meaning it doesn't read or modify contract state. It's just a helper. Could it do it in front-end using JavaScript? Yeah, but it wouldn't be as secure. Here we calculate final price on chain. I've set up mine to return prices based on the length of the domain. Shorter domains are more expensive. Since the medic token has 18 decimals, we need to put 10 to the 18 at the end of the prices. Note, you need to reduce prices to mint on the Mumbai testnet. If you charge like one medic, you're going to run out of testnet funds very quickly. You can charge anything when running locally, but be careful when you're on a real test network. Okay. Which means As for the rest, we added three things. Import, I guess whenever you call the function, you already have to pay. When you call this, the register function, because it's gonna activate this function and it's gonna return the value. Helper, I'll go over this shortly. A public string called TLD, this will record what your app domain ends with. String memory TLD in the constructor. The constructor is run only once. This is how we're setting the public TLD variable. For the new import, get this file and put it in a new folder called libraries in the contracts folder. Okay, so I need to get the file. That's why it was showing me the mistake. So I need to create what's not here. I need to create a folder here called libraries. Then and what's the name of the file? String utils. So like this, and then I copy it here. I'm not sure why it's not working. So this one seems to be fine. Let's see, string utils. The name is the same. Okay, there we go. Strings in Solidity are weird, so we need a custom function to check their length. This function converts them to bytes first, making it much more gas efficient. So, yeah, I guess here. This function here. The TLD string and the constructor changes are pretty straightforward. We will use the string later. Our contract is ready to get paid. Now we take money from everyone who wants our awesome domains. Ready for the most amazing payment experience you ever built. You know the drill. Let's head to our run.js and update it like this. So let me see where it changes. I think it's erased this line. Domain is still the same. Yeah, deployed is still the same. This line is gone. Await contract. So here it changes. And so this is probably accessing the hardhat library, utils library. And the sparse iter I also saw on the crypto zombies, where it's changing the ithers, changing to ithers. Then await const address. That's pretty much the same thing, just changed the name. And the rest is the same. I want the end of all register domains should be .ninja. This means we need to passing ninja to our deploy function to initial our TLD property. So where is it doing that? Maybe I missed something. Oh, deploy ninja. That's where. I don't think I'm gonna put a different name here. So when it's deploying, is setting up the TLD stuff on the constructor. This variable here. I think I'm gonna put .io. Or maybe something else. I don't know. Code. Let's to register the domain, we need to actually call our register function. Remember, this takes in 2 arguments. The domain you want to register, the price of the domain, including gas, in MEDEC. We use a special parse iter function because units work differently in Solidity. This will send 0.1 MEDEC from my wallet to the contract as payment. Once that happens, the domain will be minted to my wallet address. Yeah, so when you call the function, it asks for the money automatically, I think. That's how easy it is, as long as you have payable on the thing. Like here. I guess every time you put that, then it automatically asks for the payment when you call the function. That's how easy it is taking payments with smart contracts, no silly payments processors, signups, random credit card fees, one line of code. Go ahead and run your script. Okay, so let's see if it's gonna work. It's just this simple contract code. You were essentially able to get the main actions of our INS ready to go. Take a moment to appreciate the hype here. It doesn't stop here though, we are going to make this domain 10x cooler with some NFTs. Non-fungible domains. We're going to be doing something magical here, turning our domain mappings into NFTs. If you head to OpenSea today and you own an ENS domain, you can actually see something like this. We're going to do exact same thing. I wonder if this works the same way that sites do, though, or if it's just the NFT. Or then after you do this, because it doesn't seem to make a lot of sense actually. Like, can you... Maybe I should test it out. Just try to go to this address there and see what happens. I guess, yeah. Then the NFT is gonna point to the data that contains the site. I'm not sure how this works. I think I'll write it down here. Yeah, boy, Alec. Yeah, it doesn't exist. So I don't think it works exactly like the domain does. Yeah, because then you would have to host it on the blockchain, and it doesn't work. So it's not quite the same thing, unless I'm misunderstanding something. Why do we need to make our domains NFTs? What's the point? Well, if you think about traditional Web2 domains, they're already NFTs. There can only ever be one domain for each name. Multiple people can't own the same domain. When you buy a domain, you actually own and control the only copy on the entire internet. So you're just bringing that over. But even better, because you can transfer this very easily. At the end of the day, your ENS domain is just a token, right? Let's go ahead and solidify our domain on the blockchain forever with an NFT. Before we dive into the code, let's go over what we are actually going to do here. Another thing is I also don't think they talked about how to set up the network. So when you're running this code, where is the contract actually going? Where is it being deployed to? I think it's the test net for now. Maybe they'll talk about this on the next sections. Use the contracts from Open Zeppelin to easily mint ERC 721 tokens. Create SVGs for NFT and use our on-chain storage. Set up token metadata and mint it. At the end of the day, we want to take our newly registered domain, create an NFT out of it. This is all the code changes we need right now. This will be explained step by step right after. So it's on the same contract as before. Just adding these imports. This thing that I don't know what it does. Helper function. And then now is inheriting from the ERC 7021 storage. Using counters for counters dot counter. I guess this is the SVG thing. Yeah, I don't know how this other stuff works. This ERC token. So here is the same. And the price is not here. Oh, so it just didn't add the price. So register Ewing's price name. So this is the same. And this is where it changes. I guess it took out this message here. I think I'm just gonna copy this. So, and then at the end, there is one more thing. We still need the price get address. Okay, so let me see what's happening here. So it's requiring that the address is the address in the mapping there. Just to check if it exists already. Then it's calling the price function to set the price based on the length of the string, and requiring that the wallet has a bigger amount than the price. I don't think I changed the price as well. Oh no, it's correct. But here is you went through 56. Combine the name passed into the function with the TOD. And this joins the name to make the domain name. Using the encode packet. Then creates this SVG image for the NFT. What is this? Oh, it's from here. So now it's joining this with this and these two strings with the name in the middle. And tokens id.current, which is probably from the library somewhere. This new base 64 thing. Then the same thing to get the length of the name. Oh no, here's the base 64. So I'm not sure what this does. Where is it declared? Oh, it comes from. No, it doesn't come from the arguments. Yeah, I have no idea where is this coming from. Oh, here. It's here. So it's an object for with these counters here, which I don't know what it is. It's from the Open Zeppelin library. Shop keep track of token IDs. So it's a library that helps you keep track of the tokens. And then it has this method called current, probably to access the current ID. And then uses this string code, bytes strings, and then creates this formatted string here. We still need the price get address. Okay. This might seem overwhelming, we're not here. Padawan. I'm the Kenobi, your Skywalker. Just please don't betray me like the movies. Let's take it from the top. Just like with string utils, we're importing existing contracts. This time we're importing them from Open Zeppelin. Then we inherit them using URC 721 URI storage. When you declare the domains contract, you can read more about inheritance here, but basically it means we can call other contracts from ours. It's almost like importing functions for us to use. So what do we get from this? We're able to mint NFTs using the standard known as URC 721, which you can read more about here. Open Zeppelin essentially implements the NFT standard for us and then lets us write our own logic on top of it to customize it. That means we don't need to write boilerplate code. It would be crazy to write a HTTP server from scratch without using a library, right? Similarly, it'd be crazy to just write an NFT contract from complete scratch. As for base64, it has some helper functions created by someone else to help us convert the SVG used for our NFT image and the JSON for its metadata to base64 in Solidity. Create a file named base64.sol in the libraries folder, libraries, and copy paste the code from here into there. Next, at the top of your contract, you see counters. What the fuck? Why do we need a library to count stuff? We don't need one, it's just better to import one that is gas efficient and built for NFTs. So this, we're going to be using token IDs to keep track of the NFT unique identifier. It's a number that's automatically initialized at just 0 when we declare a private tokens ID. So when we first call register, new record is 0. When we run it again, new record will be 1, and so on. Remember, token IDs is a state variable, which means if we change it, the value is stored on the contract directly. At this point, we're telling our contract to bring in all the ERC 721 contract info we want to inherit. The only thing we need to provide are the NFT collection's name, I called mine ninja name service, the NFT's symbol, I called mine NNS. This is your time to shine. Make sure to change this to whatever you want. Now we're going to design our NFT. This is a very important part of your app. The NFT is what everyone will see in their wallets and on OpenSea. It needs to be really freaking awesome. The NFT is what? Design our NFT, okay. This should be really freaking awesome. You're actually going to be storing your NFT on the blockchain, on the Polygon blockchain itself. A lot of NFTs are just links. So this is just redundant stuff. So I guess this is the design of the NFT. Use Figma to make this one. Head to this website and paste in the code above to see it. So where do you put this code? Oh. So I guess here's where the name goes. And it probably goes automatically from the contract into there. This is really cool because it lets us create images with code. SVGs can be customized a lot. You can even animate them. Feel free to read up more on them here. Once you're done with your NFT, make sure you hit optimize on this SVG viewer website. That will compress them so they fit in your contract. Jam for Mortal Kombat theme songs. Make sure you customize your SVG. Maybe you want a rainbow emoji instead of the polygon logo. If you're so bold, you could even try an animated SVG. The contracts have a length limit. Don't make an incredibly complex SVG that is super duper long. The way ENS does it is they generate the SVG using a web server at the time of registration and start it off-chain. We can do something similar. So yeah, this part is not really clear to me how it is connected. I'm not sure if that code goes on the contract here, on this part of the, it's not on the base salting. So where is it? Yeah, this part here, probably not. Yeah, I don't understand it really well. Also, it's here. Oh, it's because it's in one line. So it's these two strings here. I think I get it now. And then the name goes in the final here. The final string. Yeah, and this creates the whole string, putting together the first one and the second one. Now I think I understand. And the reason why it separates them into two is so you can put the name in the middle there. Basically, all we're doing here is creating an SVG. Let's take a look. Okay. Half of this, the only things we have cards, token this, and JSON things. For JSON, NFTs use JSON to store details like the names, description, attributes, and the media. What we're doing with JSON is combining strings with API.encode packets to make a JSON object. We are then encoding it as a base 64 string before setting it as a token URI. All you need to know about token IDs is that it's an object that lets us access and set our NFT's unique token number. Each NFT has a unique ID and this helps us make sure of that. The two lines below are the magical lines that actually create our NFT. So did I copy this or? Oh, these ones. But where is this coming from? I added a console log that will print the final token. So I don't know where these functions come from. Save mints and set URI token. Maybe it's coming from the libraries that they imported. Probably. But I'm not really sure. Mint an NFT domain locally. We are ready to run our contract. Everything seems to be in order for us to generate a spicy domain NFT and mint it on our own blockchain. You can just run npx or that to get going. The big difference is what the console outputs looks like. The only thing that I don't understand is where these functions come from. Oh, and I didn't import the. I don't think they showed the file as well. Maybe I missed the part that they talked about the file. Oh, here. I think I can call. I'm probably gonna put this on favorite because I might use it later for some reason. So I need to create a different file here. Base 64, that's all. Then copy this code from here. And this should solve the issue there. Yeah, so I think it worked. Oh, let me see if these functions come from this file. Yeah, no. Maybe we can do just Control F to check. And there's only one instance. Maybe F12. Oh, here it is. Internal virtual. Yeah, so it's probably from. Oh, it comes from Node modules. Yeah, it comes from OpenZeppelin. The OpenZeppelin library. From this token here. URC 721. Which is the library for the NFT stuff, I think. Yeah, so that's explained. Yeah, so this is the URI thing. If you copy the token URI and paste it in the browser, you see a JSON object. If you paste the image blob inside the JSON object in another tab, you get your NFT image. So I think it's telling me to, well, it's including the data. So if you paste this here, you get this object, and paste this object. Doesn't work. So maybe I did something wrong there. If you paste the image blob inside the JSON object, also just the image, you get your NFT image. So I think it's this thing here. This giant string. Also didn't work. Yeah, the thing is I'm not getting the image stuff. Yeah, so I'm just getting this part here. And it's not, this part is not showing up. Oh, it's here. It is showing up. So I need to have, I need to get all of this, I think. Probably from here to here, maybe. Oh, there we go. Nice. Take a breath. Just on the back. This is stuff. Visual. Post a screenshot of your awesome custom NFT. Domain in progress. So I think we're just gonna take a picture of this and then send it there. Everything is feeling. I wonder if I can see the how many lessons there is sure in each section to see how long where I'm at on the course path. Yes. Okay. So I think I'm gonna stop here and probably come back later. Yeah, I don't think I can see the lessons. Oh, there we go. So there's only one to finish the first section. On the other sections seem like they're shorter. So I think I'm gonna stop here and I'm probably gonna come back later. I'm gonna take a break now and finish this one. Probably do the second one also. So see you then.